review. So first off, AC is a diameter. Okay? This is diameter right here. Which means this arc is 180 degrees. Now, to find BC, we also need to find out what AB is. Now, AB is formed by ACB. So remember, it's not 30 degrees because this has a vertex on the circle, not in the center. Okay? So if this was coming like this, and this said 30 degrees, well, there we go. We'd be right where we need to be. But we're talking about this angle. So remember, it's a 2-to-1 ratio, so that means this is 60 degrees. So if we add those two together and subtract from 360, then the measure of BC, the arc, is going to be 120 degrees. All right? Similar concept here. This arc is formed by RPQ. So what we need to do is add these two together, subtract from 360, and find out that this is 212. Since it's not coming from the center and P is on the circle, the angle is half of that, which is 106 degrees. All right. We're trying to find EH, which is formed by EGH. Since this angle right here is 42 degrees, and G is on the circle, this arc is 84 degrees. All right, lines of symmetry for the figure. Lines of symmetry are basically where can you fold the shape and have it be the same. Okay? So if I folded right down the middle, the left side would match the right side. And that's it. I can't do top to bottom or anything like that. So the answer here is 1. For this one, since the opposite angles are equal, I could fold it this way. I could also fold it that way. So 2. This one I could fold straight down the middle, left to right. Could fold it top to bottom. I could also, if I folded it diagonally like so, or diagonally like so, it would match up. So that is 4. All right, finding angle and arc measures. New theorem. Tangent and intersected chord theorem. Okay, so if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So let's look at this. The measure of angle 1, which means right here, is going to be half of this arc right there. And the measure of angle 2 is going to be half of whatever that arc is right there. So let's see this in action. M is tangent. Find the measure of the red angle or arc. So we have this angle right here, and this arc is 130 degrees. Therefore, angle 1, the measure of angle 1 is half of that, 65 degrees. All right, same concept here. So we have an arc formed by this angle right here, a chord and the tangent. Going the opposite direction, since this is 125 here, that means the arc, so the measure of LK, arc LK, is 250 degrees. All right, intersecting lines and circles. So we can have two lines intersect on the circle, inside the circle, or outside the circle. And that's just a concept. Now, if the lines cross inside the circle, we have a theorem for that. The measures of each angle is 1/2 the sum of the measure of the arcs intercepted by the angle. Okay? Which, if you think about it, makes sense. Okay? We'll get into this. So, a measure of angle 1 is 1/2 of this plus this. Okay, so the measure of angle 1 is equal to 1/2 those two arcs. And the measure of angle 2 is 1/2 of this arc and that arc. So let's look at that again and read it again. If two chords intersect inside a circle, the measure of each angle is 1/2 of the sum of the measures of the arcs intercepted by the angle and its vertical angle. So we'll be practicing that, so it'll make more sense once we do it. Now, if the lines are outside the circle, we also have three options here. So, if a tangent and a secant, which is the first example, because we have a tangent here and a secant going through, or two tangents, or two secants. The measure of the angle is formed is 1/2 the difference of the measures of the intercepted arcs. So what we're going to do here is take this arc and this arc, AC and BC, and subtract them. Obviously the bigger minus the smaller, and divide by 2. So again, on this one, on the second one, PQR, which is going to be this arc, minus this arc, divided by 2. And on this one, XY minus WZ. So let's see that in action. All right, so inside the circle, we're trying to find X. So this arc is formed by that angle. Okay? That angle has a vertical angle right here, which forms this arc. So what we're going to do now is add those two numbers and divide by 2. So X equals 1/2 of 156 plus 130. Okay, so that's going to be 286. We're going to divide by 2 and say X equals 143 degrees. Now in B, we have a secant and a tangent outside. So what we're going to do is take the bigger arc minus the smaller arc and divide by 2. 178 minus 76. Again, you can think about it, divide by 2 or multiply by 1/2. It doesn't matter. So 178 minus 76 is going to be 102. Divided by 2 is going to be 51 degrees. Another concept, not theory, just concept. A circumscribed angle is an angle whose sides are tangent to a circle. So in the previous examples, we said we could have a secant and a tangent, two tangents, or two secants. Well, if we have two tangents, it's called a circumscribed angle. Okay, next theorem. with the circumscribed angle theorem. The measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. Let's see what we're talking about here. So this tangent right here, these two tangents, have an intercepted arc right here. Okay? What it's saying is the measure of this circumscribed angle is equal to 180 minus the measure of this angle, which forms the same arc. So if we know what ACB is, we subtract it from 180 and we'll get D. So let's try that. We have an arc right here. Let's try it again. We have an arc right here. Nope. Try it again. This arc right there is formed by those two tangent lines, circumscribed angle, but also formed by this central angle. So we're going to take 180 minus 135 to find out the value of that angle. So that means x is 45 degrees. Right? Now, B's a little tricky. Okay? We're kind of working backwards here. So, this is equal to 180 minus 30. So 180 minus 30 is 150. So what that's telling us is this angle, this arc right here, is 150. Now, that means the central angle right there is 150. But we're looking at an inscribed angle right here. What's the relationship between the arc and that angle? Half. So we need to divide by 2. So x is 75 degrees. Okay, last one. The northern lights are the bright flashes of colored light between 50 and 200 miles above the Earth. A flash occurs 150 miles above the Earth at point C. What is the measure of BD? So BD being the arc right here, top of the Earth right there. The portion of Earth from which the flash is visible. Earth's radius is approximately 4,000 miles. So this line right here is 4,000. So let's see how to do that. Now there's a very long, convoluted way of doing this, and I'm just going to kind of run through it real quickly. You don't have to write anything down, just listen so you can kind of understand. This is putting together everything that we've done so far. Okay, so this line and this line are tangents, right? Okay, which means they're parallel here and here to the radii. Okay. Now, what we also know is these are both 4,000. Okay. And what we know is these are equivalent and these are equal. Okay. So by side angle side or HL, we know that this triangle and this triangle are congruent. Okay? So, if we know the distance here is 150 miles above the Earth, okay, what we can basically say is, sorry, board's off a little bit. Now we would take that concept and go a little bit further, but I'm going to just stop there and use the concept of congruent triangles to do it with something we already know how to do, and that's using trigonometry. Okay, so if you think about it, this angle right here, that doesn't show up very well, this angle right here, and this angle right here are going to be equal, because we just talked about them being equivalent triangles. So we can find BAC and double it, we'll be able to find the measure of the arc, because we'll have a central angle. So if we think about this as a triangle here, and this is 4,000, and let's go back up a little bit. This is 4,150. Okay. Well, what do we have? From this angle, we have the adjacent side and we have the hypotenuse. So adjacent and hypotenuse is cosine. So if we take the inverse of 4,000 adjacent over hypotenuse, we will get about 15.5 degrees. Well, then all we do is double that, and that gives us 31 degrees. So that tells us that the central angle right here is 31 degrees. Therefore, the arc right there, BD, is also 31 degrees. And that's our answer.